Hello students, we had completed the exercise 1.1 in the previous video of the NCERT text. We had seen how to find the HCF in that exercise, Euclid's division lemma and Euclid's algorithm to find the HCF. Now moving forward, let's do a little bit of arithmetic. Everybody is comfortable with multiplication? Yes, everybody is comfortable. Okay, do you remember what is a prime number? Any idea? Let's say I take the number 7. Can you express it as a sum of two numbers? Product of two numbers. Okay, let's first try it as a sum of two numbers. What can we write? 5 plus 2. Or we can also write 4 plus 3. Or we can also write, what can we write? 6 plus 1. And so on. There are so many options. Maybe we can write 8 minus 8 plus minus 1 also. Enough. So this number 7 can be written as a sum of two different numbers in so many different ways. Is there any limit to the number of ways in which we express the number as sum of two different numbers? Let's say take another number 12. How many ways can we write it as a sum? Yes, 12 plus 0, that's also one method. 12 is a number, 0 is a number. We can write it this way. Or we can also write 11 plus 1. Or we can also write 13 minus 1 and so on and so forth. Okay, if you want to remove this negative part, we can remove that also. But still we will have so many different ways. 10 plus 2 and so on. So what I am trying to say is you can express any number as a sum of two different numbers in many different ways. You can express any number, let's say there is a number, let's say this number, and you have to break it into two parts, just two parts, n1 and n2, such that n1 plus n2 is equal to n. And there are many ways to do this, n1 and n2. Henna. If you wanted to write as sum of three numbers, n1, n2, and let's say there is one more n3. Again, there can be many different ways, isn't it? Similarly, can we write this 7 as a product of two different numbers? We are not interested in sum over here, we are interested in product. What can we write it as? 7 into 1. Or you can also say 1 into 7. Is there any other possibility? No. With multiplication, there is no other possibility. With multiplication, there is only one possibility, which is 7 into 1 or 1 into 7. Let's say we'll write it in the ascending order, so we'll just consider 1 into 7. We'll not write the numbers in descending order. First, we'll write the smaller number and then the bigger number. So there's only one way to express it as a product of two numbers. And one number is the number itself. One number is the number itself. Will this always happen? Let's say I write 27. What can this be written as? 3 into 3 into 3. Or it can be written as 9 into, okay, I'll write it in descending order, 3 into 9. Or we can write 1 into 27. There are three possibilities. There are only three possibilities. And basically this and this are the same. We have the similar numbers. So we can express 27 as a product of two numbers in more than one way. More than one way. You see, here for number 7, there was only one way possible. And for number 27, we have two different ways at least. Okay. So the number which cannot be expressed as a product of other numbers in more than one way is called a prime number. Of course, you all know it. What is a prime number? You cannot express it as a product of any other number. Prime number cannot be expressed as a product of any other number. Let's take one more example. Let's take 19. Can you express it as a product of any other number? No, you can only write 1 into 19. Let's say you take 61. Can you express it as a product of two numbers? Can you break it down? No. 61 will remain 67 itself. It can only be 1 into 61 and no other possibility is there. है ना? So that is a prime number. You cannot express it as a product of two different numbers. What is a prime number? The number which cannot be expressed as a product of two numbers is called a prime number. Very simple. Okay. Now let's see which numbers which are not prime. Numbers which are not prime, like 27. Let's take one more example. Let's take 30. 2 into 3 into 5. This is what 30 can be written as. है ना? If you take 210, what can you write it as? 2 into 3 into 5 into 7. You can express these numbers as a product of other numbers. 30, 210 or any number. You can express the number as a product of other numbers. Such number is called composite number. ठीक है? So, is there any other possibility if we classify the numbers as prime and composite? Let's try to classify the numbers as prime and composite. Prime number will have the number itself. You cannot break it down. 7 will remain 7 itself. You cannot divide it into any other number. However, some numbers can be divided like 27, 60, 210. 6 can also be divided. 3 into 2. 4 can be divided. 2 into 2. So numbers which can be expressed as a product of other numbers is called a composite numbers. Numbers which cannot be expressed as a product of other numbers is called a prime number. Is there any other possibility? नहीं हो सकती ना. How can there be a possibility? Either you can break down the number or you cannot break down the number. Yes or no, there are only two possibilities. If you can break it down, it is composite. It is not a prime. If you cannot break it down, it is a prime number. ठीक है? So we have come to the conclusion that number can be either prime or composite. There are only two types of numbers. ठीक है? Now, see the special thing about the composite numbers. 6. You have expressed it as a product of 3 into 2. Now, in the right hand side, 3 is a prime number, 2 is also a prime number. In the right hand side, 3 is a prime number, 2 is also a prime number. है ना? So, we have expressed a composite number as a product of primes. See this 4 here, 2 into 2. We have expressed this number 4 as a product of primes. You cannot break down this 2 anymore. See this 210 here. We have expressed it as a product of primes. 2 into 3 into 5 into 7. So every number can be expressed as a product of primes. ठीक है? We will not consider this 3 into 9 over here. 27 can be expressed as product of primes as 3 into 3 into 3. 3 into 9. Here 9 is not a prime. 9 is not a prime. So we are not going into that kind of factorization. 9 is not a prime. So we are not interested in this kind of things. We are interested only in product of primes. So we'll try to express any number as a product of different prime numbers. Okay. Let's take some examples. Let's take what? Tell any number. Let's write it in black. 24. What can we write it as? 2 into 2, 4 into 2, 8 into 3. We have expressed it as a product of different prime numbers. 2 will come 3 times, 3 will come 1 time. Now, is there any other way possible? Is there any other possible way? To express 24 as a product of primes? Now, we will not consider 2 into 3 into 2 into 2 as a different way. We will not consider this to be different because both of these things are equal to 2 to the power 3 into 3. So, any other possibility to express 24 as a product of primes? No, there is no other possibility. Let's take one more number. Which number do you want to take? 120. 2 to the power 3 into 3 into 5. Any other possibility here? No, only one possible way. Henna. That means there is a unique way to express a composite number as product of primes. Are you getting it? There is only one way possible to express any given number as a product of primes. Let's take one more example. Factorize 32760. 32760. Let's say we divide it by 2. What will you get here? 16380. Again, let's say you divide it by 2. What do you get? 8190. Again, divide it by 2. What do you get? 4095. Now, can you divide it by 2? No, it's not possible. Can you divide it by 3? Of course, you can divide it by 3. What will you get here? 1365. Can you divide it by 3 now? Of course, you can divide it by 3. What will you get now? 455. Can you divide it by 3 now? No, it cannot be divided by 3. Can you divide it by 5 now? Yes, you can divide. You will get 91. And then what can you do? You can divide it by 7 only and nothing else. 7 in, and here you will get 13. So what can you write this number as? 2 to the power 3 into 3 square into 5 into 7 into 13. This is equal to 32760. There is only one way, and this is that one way to express the number 32760 as a product of primes. ठीक है? ठीक है ना? We can factorize. This factorization is required to find the HCF, and we have learned another method wherein we don't need to factorize the number to find the HCF. You are familiar with all these things? So now we can come to the fundamental theorem of arithmetic. The fundamental theorem of arithmetic says every composite number, take any number, every composite number can be expressed or factorized as a product of primes And this factorization is unique apart from the order in which the prime factors occur. As we have done it in this case, we can factorize this number 32760 only among these numbers. Changing the order of numbers is insignificant for multiplication. We all know that for multiplication, the change order of numbers in which we write, order in which we write the numbers is not important. The numbers themselves are only important. Let's say instead of 2 cube, we can write this number as this also. So 2 cube into 5 into 7 into 13 into 3 square. Will anything change? No, nothing will change. You will get the same number. So this is what the fundamental theorem of arithmetic says. Take any number p, it can be divided by some prime numbers or it cannot be divided. So if the number is prime, it cannot be expressed as a product of other prime numbers. If it is not a prime number, it can definitely be expressed as product of some other prime numbers. Are you getting my point? Any number n, it can either be prime. If it is prime, it cannot be expressed as a product of other prime numbers. If it is composite, there is one unique prime factorization of that number. There is one unique prime factorization of every composite number. So see this example. Consider a number 4 to the power n where n is a natural number. Check whether for any value of n for which 4 to the power n ends with digit 0. So 4 to the power n can take any natural number value. So it can be 4 to the power 1, it can be 4 to the power 2, it can be 4 to the power 3 and so on, and can take any number. Maybe 4 to the power 100, maybe 4 to the power 1000, and can be any number. So among all these numbers, so many numbers that we have, can any of these numbers end in a 0? Can any of the number have a 0 at the end? How can you decide? Seems a difficult question. No, it's not so difficult after all. क्या कर सकते हैं हम लोग? क्या कर सकते हैं? कैसे पता लगा सकते हैं? देखो, नंबर में if you want to have a 0 at the last of a number, if you want to have a 0, that means number will be divisible by 5. If any number, let's say any number, it is ending in 0, last में 0 है तो it is a multiple of 5. So prime factorization will have a 5. If the number is ending in 0, its prime factorization will have 1 5 at least. It will have at least 1 5. Even if there is 1 5, that will appear in the prime factorization. And what can be the prime factorization of 4 to the power n? 4 to the power n is equal to 2 into 2 whole to the power n, that is equal to 2 to the power 2n. How can 5 appear in this prime factorization? 5 cannot appear in this prime factorization. In the factorization 2 to the power 2n, 5 cannot appear. If 5 cannot be there, the number cannot end in 0. Magic लग रहा है? Miracle. You don't know what is the number. And there are so many numbers: 4 to the power 1, 4 to the power 2, 3, 4, 5, 6, 100, 1000, 10,000, 4 to the power 10 lakh, 4 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Any number. None of those numbers can end in a 0. And that has been proved now. That has been proved. The prime factorization, you want to write it. Prime factorization of 4 to the power n cannot have a 0. So cannot have a 5. How do you know this? By fundamental theorem of arithmetic. By fundamental theorem of arithmetic, you already know that. And when 5 is not there in the prime factorization, number cannot end in a zero. ठीक है? That was very simple. Okay, we'll see more questions in the coming class. Thank you.